Hello everybody and welcome to Chapter 10 on polynomials. We finally hit the last week of our quarter and we're having the most fun. I swear this is the best chapter right here. This is one of my favorites because it really gets us ready for the basis of the algebra class. So what are we going to cover today? Well, we're going to go through a little vocabulary. Most of it we already know, but we need to make sure that we understand these terms. And then we're going to add and subtract polynomials. We're going to go through a few exponent laws. We're going to review the distributive law, and then we're going to work it in reverse. And then we're going to multiply some polynomials, and we're going to talk about scientific notation. Some of this might not exactly be in this order, as I'm going to shuffle in the distributive law a little bit early, and then return to it a little bit later to talk about the reverse. But those are the concepts that we are covering in Chapter 10 on polynomials. So going through our vocabulary, we need to make sure that we are aware of what we're talking about. Now, polynomials is a pretty big word. We need to be able to understand what that means. Now, Polly wants a cracker? No, not that kind of Polly. Poly means many, or lots of them. And nomials comes from the Greek root word for numbers. But we want to be a little bit more specific as to what type of numbers are we really using here. And the type of numbers that we're really going to be using are terms. And so polynomials simply means that we're going to have many terms. Okay. Now, what's a term? We've got to remember what that is. Remember, I said that is one of the key concepts that we need to leave this class with, is knowing what is a term. Okay? Now, a term is a number, a variable, or a product of numbers and variables separated by addition. Do I need to write all that down? Maybe I'll take a moment to do that. So once again, it's a number, a variable, or a product of a number and a variable or variables separated by addition. Now, if we don't understand the words in the definition, we're not going to understand the definition itself. So let's make sure we understand each part. A number, okay, we're good with that. A variable. Variable is just another way of saying a letter. Okay. A number or a letter or a product. Product, that's another weird one. Product means the answer to a multiplication. So we're going to be multiplying a number and variable, or variables, because you could put more than one variable together. And the terms are separated by addition. Notice the spelling of separated. The E's are separated by the A's, or you can say that there's a rat inside of it. Anything so that you start spelling it correctly. Separated by addition. Okay, so what are some examples of terms? Well, a number, 12, there's an example of a term. A letter, Z, that's another example of a term. A product of a letter and a number. How about 12Z? Haha. And then we can put these terms together. So I can put a few terms. I can say, okay, how about 12Z plus 14? Now I have two terms. 12Z is a term and 14 is a term. And the two of them are separated by the plus sign. That's how one term ends and the next term begins. Okay. Now, we also need to be aware that terms are separated by addition, but what happens if I have something like 3x squared minus 4x minus 1? I don't see any addition there. But remember, subtraction is the same thing as adding the opposite. So there's three terms there. The first term is the 3x squared. The second term is the negative 4x because the sign in front of the term goes with the term. Because remember, this is adding the opposite. Remember change, change? And so we have a negative 4x here. And the same thing for that last one. We do a change, so it's plus the opposite. And we have a negative 1. So the three terms there are 3x squared, negative 4x, negative 1. Okay. Coefficient. That's just a big way of saying the number in front of the letter. Number in front of letter. So in that expression that we just did, the 3x squared minus 4x minus 1, the 3 is the coefficient on the x squared. The negative 4 is the coefficient on the x. Now, is negative 1 a coefficient? Well, there's no variable there. So they decided to have a new name for it. So instead of calling that a coefficient, we call that the constant. So the constant is the number with no letter. So that would be the negative 1 in that example up there. Okay. So the coefficient is the number in front of the letter. If the number doesn't have a letter, it's called a constant. Putting all of these terms together, a bunch of terms together, makes a polynomial. I call those choo-choo trains. The choo-choo train has to be attached by either a plus or a minus sign, and that's how they are coupled together to pull out of the station together. We have the standard form of a polynomial. The standard form of a polynomial is to put the highest exponent first. Highest exponent first. And then in decreasing order. Now the exponent is the exponent on the variable. Our numbers won't have exponents on them because we would simplify that and get rid of them. So notice on that problem that I put up there, let me rewrite it down here again. We had 3x squared minus 4x minus 1. I put the x squared term first, then the x, and then the constant is the caboose. The constant is the caboose. It's always the last one. Okay. So the highest exponent was the x squared, so that term went first, and then in decreasing order. What's the exponent on this x here? If there's nothing up there, the God of Mathland is always with us. He, she, it is sitting on our shoulder. Every number has an exponent. The exponent is a 1. We just don't see it because we're not going to write every single number with an exponent of 1 up there. I mean, literally, this 3 could have an exponent of 1 on it. The 4 could have an exponent of 1. The x has an exponent of 1. The 1 over here has an exponent of 1. We'd have all these little 1s hanging around. We don't need that. God needs to be with us, but not necessarily seen. So if there's no exponent up there, it's always a 1. We just don't see the God of Mathland sitting on our shoulder all the time. He, she, it likes to hide, but he, she, it is always there. Okay, so that's the standard form of a polynomial. You put your highest exponent first, and then in decreasing order.